Welcome back, everybody. Today we are going to be looking at lesson 10-3. Lesson 10-3 is on special products of binomials. So we learned about FOIL and boxes in our last section. And this section, then we're going to be talking about what happens when a couple of special things happen. So there's some rules that happen in some special situations. So we're going to be looking at those today. So let's go ahead and get to our notes and we'll get started. So you should have been given a paper that will go into your notebook that looks like this. And this piece is going to kind of guide us with how to do special products. So this is lesson 10-3. And it is on special products of binomials. Okay, so up to this point, we have been talking about foiling things where we know what the two factors are. And we said that we can either do FOIL, first, outer, inner, last, or you can do the boxes. So this is a 2 by 2 or a binomial times a binomial. So therefore we would make the boxes. So if we did FOIL, we would do first times first, which would be 6x squared. We would do outer times outer, so 2x times 16, which would be 16x. We would do inner times inner, which is 1 times 3x, which is just 3x. And we would do last, which is 1 times 8, which is just 8. And then we would add them together and get 16x squared plus 19x plus 8. And that would be using FOIL. So we're going to do the same thing, but this time with boxes, where I would put the binomial 2x and then a plus 1. And over here, I would put a 3x and a plus 8. So this is a binomial times a binomial. That's why I do a 2 by 2 box. If it was a trinomial times a trinomial, we would do a 3 by 3. So 6x times, 2x times 3x would be 6x squared. So they go there. And then 3x times positive 1 gives us a 3x. 2x times 8 gives us a 16x. And an 8 times a 1 is an 8. And then again, your diagonals are generally speaking going to be like terms. So that would be 16x squared plus there's my 19x plus 8. So either way you do it, you get the same answer. So we're going to be looking at what happens when we have differences of squares. So differences of squares are when you have something like x minus 2 squared. So that's a square. I have kids all the time that just want to distribute the square, and we cannot do that. We also are going to look at sums of squares, which are the same thing, except for it's a plus sign in the middle instead of a negative. And then we're also going to look at the product of a sum and a difference. And this happens when you have the same number, but one is a positive and one is a negative. So these are the three things that we're going to be looking at, and why can't they do the way we want them to do. So if we have difference of squares, I have kids all the time that try to distribute and say that this is x squared minus 4. This is wrong. You cannot do it that way. I have kids that look at this one and they try to tell me that this is x squared plus 4. Again, cannot do that way. So if we were to actually do boxes for a difference of squares, this would be an x minus 2 and an x minus 2, because this would be x, if we expanded this, it would be x minus 2, x minus 2. And so we'll find out that if we're doing this, we actually don't get this, that we actually will get an x squared minus 4x plus 4. And if we do the difference of the sum of squares where we add them together, so again, if we were to expand this to x plus 2 times x plus 2, we would get an x squared and a 2x and a 2x and a 4, which would give us x squared plus 4x plus 4. So as you can see, we cannot distribute the square inside. You can only do that when you have a monomial. These are not monomials, these are binomials. They don't actually work. So that's where this is going to come in. So we're going to go ahead and turn everything sideways, and we're going to tape this guy in. And we're going to find out that something really cool happens with these 3 things, and it happens every time. So if you know these rules, then you can use them. So the sum of the square, first of all, is the x plus a squared. So the pattern then, if I were to use boxes, gives us an x squared and an ax and an ax and an a squared. So if you look at the pattern here, when we put them together, we have x squared plus 2ax plus a squared. And so that's your rule. So x squared plus double whatever the second number is with an x on the end, and then you can square the last number. So for example, if I have x plus 3 squared, I know automatically that this is x squared plus 2 times a, and then add the x. So here's my a, right? So 2 times a, which would be 6, so plus 6a, throw an x on the end, and then square the last term, plus 9. And it works that way every time. So if I did x plus 10 squared, I would have x squared plus 2 times 10, which is 20, and then throw an x at the end, and then plus the last number squared, so 100. And it works like that every time. So let's look at the difference of squares. So again, if we FOIL the difference of squares, so this would be if we have x and then a minus a and x and minus a, we get an x squared, we get a minus ax, we get a negative ax here, and we get a positive a squared. So if we put those together, we get x squared minus 2ax plus a squared. So it looks very similar to this, with the exception of that one negative right there. So our rule is x squared minus 2 times whatever number is at the end with an x at the end plus the last number squared. So for an example, if I had x minus 6 squared, and if I have x minus, let's do 12 squared, then we know that this is x squared. And then the second one would be 2 times whatever the second number is, and then throw an x behind. So it's negative, whatever this number is, so 6 squared, or 6 times 2, which is 12. Throw an x at the end. Whatever number this is times 2, which would be 24. Throw an x at the end, and then square the second term. So plus 36. This one would be plus 144. And it works that way every time. The last one is probably my favorite, and that is the difference of sums, the sum in a product. So if you have the same number on the end, but one is positive and one is negative. So if we have an x plus a and an x minus a, we end up with x squared, and then we have a negative ax, we have a positive ax, and then we have a negative a squared. So if we put this together, we get an x squared, and then the negative ax and positive ax, those cancel each other out. So those go away. So minus a squared. So our rule is x squared minus a squared. So if we have the product of a sum and a difference, so for example, if we have x minus 3, x plus 3. So last number is the same, but one is positive and one is negative. We can literally know that the negative 3x and the positive 3x are going to cancel each other out. So we know that this is just simply ax minus, or x squared minus 9. And we know that that middle number is going to go away. So it literally is the first one squared times the second one squared. And this is what everybody tries to do with these, but they don't work. This only works when you have one positive and one negative. So another example would be, say, x minus 11, x plus 11. We know that the negative 11x, positive 11x will cancel itself out. So it's just the first term squared minus the second term squared. And that's going to happen every time. So that is all to the special products. I hope you enjoyed learning about the shortcuts. If you have any questions or concerns, want to do any more examples, feel free to come and see me. I would be more than happy to help you out. So until next time, we'll see you later.